Good morning, guys. So today we will talk about the linear function. So we'll talk about the basic concepts of linear function and a standard form ax plus by equal to c, and we'll talk about the slope, average rate of change, and the linear models. So first of all, we'll talk about the linear function, okay? So if you have a function fx equal to ax plus b for real numbers a and b, right? So you have a real numbers. For real numbers a and b, so we have a linear function is defined as fx equal to ax plus b. So this is a linear function. So if a is not equal to 0, if a is not equal to 0, then the domain is what? The domain is negative infinity comma positive infinity, set of all real numbers, and the range is also what? Negative infinity comma positive infinity. Okay? So you see, if a is not equal to 0, so that means you can simply take the, let's say if the value of a is 1, which is not 0, right? And let's say b equal to 3. So what is the linear function? It will be 1 times x plus 3, which is simply x plus 3. See that? So this is a linear function. Now, remember, if a is not equal to 0, what is the domain and range? Negative infinity comma positive infinity, right? So if you look at this linear function, what is the domain? For what values of x this function is well defined? So this function is good for any value of x, is that right? You see that? You can plug in any value of x. So this function is good for any values of x. So that's why the domain is what? Negative infinity comma positive infinity. You see what I'm talking, right? And when you plug in any values of x, you may get any real numbers. Is that right? So that's why the domain for this function is negative infinity comma positive infinity, and range is also negative infinity comma positive infinity. So you can plug in any values of x here. That makes sense? So in the domain, you can have any real numbers because domain is the set of values of x, right? And when you plug in real number x, when the input is a real number, then your output is also what? It can be any real number. It depends upon what your input is, right? If you plug in 3 here, y is what? 6. You know y and fx, they are the same thing. You know that, right? If you plug in 1, it will be 4. If you plug in 2, it will be 5. If you plug in 3, it will be 6. If you plug in 4, 7. That makes sense? Or if you draw the graph, you can easily see that. So you have fx equal to x plus 3, and if you want to draw the graph, let's say I want to plug in x equal to 0. Okay, if I plug in x equal to 0, so it will be 0 plus 3, which is 3. The 0 comma 3 is the what? Y-intercept. This is y-intercept, right? This is y-intercept. y-intercept. If we plug in y equal to 0, so what will be the value of x? So this is y also, you guys know that, right? If I plug in y equal to 0, what will be the value of x? -3. So this is -3 comma 0. This is what? X-intercept. That makes sense? So now, if you draw the graph, so this is your x-axis, and this is your y-axis. So 0, 3. You have somewhere here, 0, 1, 2, 3, right here. And then -3, 0, -1, -2, -3. So this is -3, 0. That makes sense? So now, if you draw the graph, you'll have something like this. Did you see that? Right? And now you look at the graph, you can easily figure out the domain, right? Your graph can be extended. It can be extended indefinitely to the right, to the left, up, down. Because this is an arrow here, so you can extend it indefinite like this. Are you guys with me? Right? Right? You see that? And the domain is the set of values of x. So now, did you see that? So now, if you have a point here, where is the x value? Right here. If you have a point here, where is the x value? Right here. If you have a point here, x value is here. If you have a point here, x value. For this point, your x value is here. For this point, your x value is here. So for every point on this line, right, we have an x value on the x-axis, right? So you see this, the whole real line is the what? Domain, right? Set of all real number. Did you see that? Right? And the range is what? For this point, where is the y value? Here. For this point, where is the y value? Here. Is that right? Are you with me? For this point, we have y value here. So the range is set of all real numbers. Domain. Now, what you need to know is, so let me summarize this, okay? What I'm trying to say is, hey, if you have a linear function fx equal to ax plus b, if a is not equal to 0, right, then the domain and range will be the set of all real numbers. Does that make sense? Yes. But if the value of a is 0, okay, if the value of a is 0, let's say you have fx equal to, a is 0, let's say b equal to 3, right? So you plug in a equal to 0 and b equal to 3, so 0 times x is 0, 0 times x plus 3, so that will give you fx equal to 3. Does that make sense? You see that, right? So it means for any value of x, you plug in here your y value. This is your y value. Your y value is always going to be 3. You see what I'm talking, right? So this is a constant function. Whatever the input, your output is always going to be 3. Does that make sense? So this is a constant function. Now in this case, your range is fixed. Your range is what? What is the range? What is the y value? 3. So the range is always 3. Makes sense. And your domain is the set of x values. You can plug in any x values. F of 0, 3. F of 1, 3. F of 2, 3. F of 5, 3. F of 100, 3. You see that? So the domain is set of all real numbers. So you can write negative infinity comma positive infinity. Now if you draw the graph, you see whatever, if you make a t-table here for the x value and y values, if you plug in x equal to 0, it is 3. If you plug in x equal to negative 1, it is still 3. Negative 2 is still 3. 1 is still 3. You know what I mean? So now if you want to draw the graph, you have this is your x-axis, right? So this is your x-axis and this is your y-axis, right? So now you see 0, 3, 0, 3. Where is this? 0, 3. Let's say this is not 1, 2, 3. 1, 2, 3. Right? So 0, 3 is this point. And 1, 3. 1, 2, 3, negative 1, negative 2, negative 3. 1, 3, this point. 2, 3, this point. Negative 1, 3, this point. Negative 2, 3, this point. And if you join them, you see, did you see that? And then if you join, did you see that? You see the horizontal line, right? Right? And what is the domain? Domain is the set of all real numbers, right? What is the range? Range is the number 3. Does that make sense? Yeah. So, okay. So let's talk about, so this is the definition of the linear function. And now you can, what do you think? What will be the domain and range of this function? Is this a linear function? Is this a linear function? Is this in the form of fx equal to ax plus b? Yes? What is the value of a? Negative 2. So that is not equal to 0, is that right? So negative 2 is not equal to 0, is that right? So now, so that means the domain and range must be what? Exactly. Look here. Look, read the last sentence. If a is not equal to 0, the domain and range of a linear function are negative infinity comma positive infinity. Makes sense, right? Yeah. So now you can draw the graph, like when you plug in x equal to 0, that will give you y equal to 6, right? So that is the y-intercept, 0, 6. And if you plug in y equal to 0, I think you will get x equal to 3, right? So let me show you that. So you have a function fx equal to negative 2x plus 6. I want to graph it, okay? I want to graph it. Okay. So how do you find that? You have x value and the y value. If you plug in x equal to 0, hey, if it is a function, y and fx are the same things. Okay? So now if you plug in x equal to 0, your y value will be 6. So that means 0, 6 is the, which intercept is this? X-intercept or y-intercept? Y. So this is y-intercept. And if you plug in y equal to 0, then you plug in y equal to 0 here, okay? So 0 equal to negative 2x plus 6, right? I plug in y equal to 0. So now you subtract 6 from both sides. So that will give you negative 6 equal to negative 2x. Are you guys with me? And then you divide both sides by negative 2. That will give you x equal to 3. So this is x-intercept. The value of y-intercept, right? you can obtain y-intercept by plugging x equal to 0, and you can obtain x-intercept by plugging y equal to 0, right? If you want to find out y-intercept, plug in x equal to 0. If you want to find out x-intercept, plug in y equal to 0. Make sense, guys? Good. So now, if you wanna draw the graph, look here. So if you wanna draw the graph, you have so this is your x-axis, this is your y-axis. So 0, 6. Let's say this is origin, right? This is origin, right? So 1, 2, 3, 4, 5, 6. This is the point 0, 6. And then you have what is the another point? 3, 0. So 3, 0. 1, 2, 3. So this is 3, 0. And if you have 2 points, you can draw a straight line in a plane. 2 points always determine a straight line in a plane. Right, guys? Huh? Does that make sense? You got it? Okay. So now you join them. You connect. I have to be very like this, okay? This is the. Make sense? And then you see the domain is set of all real numbers. Range is also set of all real numbers. So you got it, right? We did that, right? So now what will be the domain and range for this function? Can you let me know? Can you tell me? What will be the domain? Yeah, the domain is negative infinity, positive infinity, and the range is the set of y value, right? What is y value there? -3. And the range is, so you say you can plug in any value of x there, right? Like 0, 1, -1, -2, whatever you like. You can plug in any real value of x, okay? So now, so therefore the domain is negative infinity, positive infinity. And range is -3. Yeah. You see that? You got it? This is your horizontal line. Now this one. So domain is the set of value of x, right? What is the value of x here? -3. So what will be the domain? Yeah, domain is just -3, right? Right? But the range is, you can have what? Any y value. Yes. Yes. So the range is negative infinity, positive infinity. Domain is -3. So if you want to draw the graph for that line, so you see x equal to what? You have x equal to -3, right? You're going to graph x equal to -3. So if you want to make a table for the x values and y values, so your x is always -3. You see what I'm talking, right? It's always -3. Now you can pick y value 0, 1, -1, whatever. Right? So now if you want to draw the graph, so this is your x-axis, this is your y-axis. So now -3. So let's say this is origin, right? So this is -1, -2. And we have a what? We have a -3. Right? Are you with me? So now you have 1, 2, 3. -1, -2, -3. So -3 comma 0. So what is -3 comma 0? Right here. So this is -3 comma 0. Is that right? Huh? And where is -3 comma -1? -3 comma -1 at this point, you know, -3, and then go 1 unit down this point. Right? And where is -3 comma +1? Go 3 unit left from the origin, and how many unit up? 1 unit up. So right here. So now you see the graph is going to be the what? Vertical line like this. See that? So this is the graph of the line x equal to -3. This is a vertical line. And you see that right now the domain is -3. The range is y value. You know, like for -3, for x equal to -3, your y value can be any number from the y-axis, right? So that's why this is -infinity comma +infinity. Did that make sense here? Does that make sense? Okay, yeah. Okay, guys. Now this is the standard form, okay? So the standard form of the equation is ax plus by equal to c. So this is the standard form, and a must be 0 or positive, b and c are integers, and the greatest common factor of a, b and c is 1. So let me so a standard form this is in the form of ax plus by equal to c, right? And the coefficient a is the what? Coefficient of x. B is coefficient of y, and c is a constantum, right? So a must be greater than or equal to 0. So it should be non-negative integer. You see that, right? Greater than or equal to a is greater than or equal to 0. And a, b, and c are integers. They are integers, okay? But they are called like a relatively prime integers. So that means the greatest common factor of a, b, and c is 1. So a is greater than 0, and a, b, and c are relatively prime. Relatively prime. Or this is equivalent of saying like a, b, and c are relatively prime. So that means the greatest common factor, right, of a, b, and c is 1. Like let's say, I'll give you an example here. Look here. So if you have, let's say, a equal to 4, b equal to 5, b equal to 6, and c equal to, let's say, 10. Right? My question is, are a, b, and c are relatively prime? Now you need to find the greatest common factor. Is that right? If the greatest common factor is 1, you can say relatively prime, right? Otherwise, they are not. That makes sense? Okay. So now, hey, what are the factors of A, guys? What are the factors of A? The factors of A are, what are the factors of A? So plus or minus 1, is that right? You can say, let's consider the positive factor here in this case. 1 is a factor, right? Because 1 divides 4 exactly. Is that right? What about 2? Is 2 a factor of 4? Yes, because 2 times 2 is 4, right? So 2. What about 3? No. What about 4? Yes, right? You stop here because this is the number 4, right? So 1, 2, and 4, right? Right? And now let's find out factors of B. So B means here 6, okay? A means here 4. So the factors of 6 are, what about A? 1. Is 1 a factor of 6? 2. Yes. 3. Yes. 4. No. 5. No. 6. And now let's find out the factors of 10. The factors of 10 are, what are the factors of 10? 1,
2, 5, 10.
Yes, 1, 2, right? And then 5, and then 10. Make sense? So now, what is the common factor? What is the greatest common factor? The common factor is you have a 1 here. This is also common, right? You have a 2. This is also common. Is that right? But which one is the greatest? Which one is the greatest common factor? 2. So GCF, greatest common factor is 2. So what does that mean? That means these 3 numbers, 4, 6, and 10, they are not relatively prime. That makes sense? But, so let's say I wanna take like a 4, 6, and 7, okay? 7. So factor of 4 is same, 6 is same. What about the factors of 7, guys? What are the factors of 7?
1 and 7.
1 and 7, is that right?
Yeah.
So the factors of 7 are 1 and 7. So now what is the greatest common factor here?
1.
1. You see? Did you see that? The only common factors among these 3 numbers is 1. So the greatest common factor is 1. So the greatest common factor is 1. So that means 4, 6, and 7, 4, 6, and 7 are relatively prime. Relatively prime. So if you have an equation in the form of, let's say, 4x plus 6y equal to 7, right? Because you see the 4, 6, and 7 are relatively prime, right? So if you have an equation 4x plus 6y equal to 7, so this is a what? This is in the standard form. Is in the standard form. Did you get it? But if you have, let's say 4x plus 6y equal to 10, you see this 4, 6, and 10 are not relatively prime because their greatest common factor is not 1, right? This 4x plus 6y equal to 10 is not in a standard form. That makes sense? Okay. Is not in a it's not in the standard form. Are you guys with me? Okay. Look here. You graph this function and give the domain and range. So you can graph it, right? And give the domain and range. What do you think? What will be the domain and range? Can you figure it out? Hmm? Hmm? What do you think? What will be the domain and range, guys? Look here. So we have a ax plus, we have a 4x minus 5y equal to 0. 4x minus 5y equal to what? 0, right? So remember, I mean, like, if you graph it, you can easily figure it out. So let's do the graphing method first. So let's make a table for x and y values, okay? So if I plug in x equal to 0, what is the value of y? If I plug in x equal to 0, what will be the value of y?
The undefined one, because you divide 0 by -5.
So you have a 4 times 0, is that right? I'm going to plug x equal to 0, right? 4 times 0 minus 5y equal to 0. Make sense? Is that right? So what is 4 times 0?
0.
0. 0 minus 5y equal to 0. What is 0 minus 5y? So 0 minus 5y is negative 5y. Is that right? Equal to 0. So you divide both sides by what? Negative 5. Yes, yes, negative 5. So you cross them out. So what will be the value of y? What is 0 over negative 5?
Wouldn't that make that undefined?
Undefined is if you have a 0, something over some number over 0. You know what I mean? Like negative 5 over 0, yeah.
Right.
But here, 0 is in the numerator, right? Undefined, you will have undefined if you have a 5 over 0 or negative 5 over 0. This is undefined. So division by 0 is not allowed. Okay? But this is 0 over negative 5 is what? 0. Makes sense, right? So now this is 0. Now let us take another point, okay? What do you want to pick? Like x equal to what? 2. That's good. That's good. So you can pick 2, but if you pick 2, you will not get an integer value. You know what I mean? You will get a decimal number, and it's kind of like a hard to plot. But you can pick it. How can you pick a value of x such that when you plug in here, it will give you integer value of y? Yes, if I plug in x equal to 5, if I pick x equal to 5, right? Okay, so 5 times 4 is 20. Are you guys with me? Right? 4 times 5 is 20 minus 5y equal to 0. This is same as 5y equal to 20. Are you guys with me? Yes? And what will be the value of y? Huh? 4? Right? So that will be 4, yeah. So if you have a 2 point, then you can draw the graph, right, in the plane. In a plane, if you have a 2 points, you can draw the graph. So you have This is your x-axis. This is your y-axis. You have a point 0, 0. This is the 0, 0 origin, right? And then you have a 5, 4, right? So that means from the origin, you go 5 unit right, 1, 2, 3, 4, 5 unit right, and 4 unit up, 1, 2, 3, 4 unit up. 5 unit right, 4 unit up. These 2 points, right? And then you join them. You see? So this is the graph of what? That one. Make sense? So now you can easily tell me, you know, like what will be the domain and range? Look at the graph. What will be the domain? What are the x values?
0, 5.
Why? Like look here at x values. Like if I have a point here, where is the x value? Right here. If I have a point here, where is the x value there? If I have a point on the line, you have x value here. You have this x value here. If you have this x value here. So, and then you can extend this line indefinitely in either direction. Is that right? Right? So what will be the domain? Yes. The domain is negative infinity, positive infinity. And what will be the range? Yeah, negative infinity, positive infinity. So this is the one way, right? So remember, when we define a linear function, if a is not equal to 0, right, then the domain and range of the linear function is negative infinity, positive infinity. Remember that? Now this is exactly, if you write that, this, let's say I want to write, I want to write in the form of fx equal to ax plus b, or y equal to ax plus b, right? Okay? I want to solve for y. Are you with me? So if I move this to the right side, it will be what? 4x equal to 5y. Did you get it? And then you divide both sides by 5. So you divide both sides by 5, right? And then you cross them out. So that will give you, so it would be, you see y equal to, are you with me? Y equal to 4 over 5x. And I told you this y and fx, the same thing if it is a function. Remember that? So you can replace y by fx equal to what? 4 over 5x. And now this is in the form of this, where b is 0. B is 0, what is a? What is the value of a? 4 over 5. And a is not 0, right? So remember, if you have a linear function this with a is not equal to 0, then remember domain equal to range equal to negative infinity, positive infinity. We did that, right? So that is another way of explaining this. Does that make sense? Okay. Good. Okay. So now we define slope, okay? The slope is the measure of steepness, right? Or you can think like a slope is the measure of orientation of the line, you know, like you know the slope in a real life, right? So but geometrically or mathematically we define it as a ratio of rise to run. Okay? So slope if you want to define slope geometrically, slope, it is denoted by the letter M, and it measures the steepness or the orientation of the line. But geometrically, it is defined as what? Rise over run. And the run is the horizontal distance. Change in horizontal distance is run, and change in vertical distance is rise. So if you have a line, and if you want to find out the slope, we only need 2 points to find the slope of a line. Okay? You see what I'm talking, right? If you want to find out the slope of the line, you only need 2 points. Okay? So let's say you want to find out the slope of this line, okay? This line. You want to find slope, right? And now you only pick 2 points. You only need what? 2 points, okay? Use 2 distinct points. So let's say I want to take like this point and this point. Right? Are you with me? I want to find out slope of the line, okay? What I need? I need 2 distinct points. So I pick these points. So let's say this is x1, y1. And I want to pick this point. Let me write down here. So this is x1, y1. The coordinate of this point is x1, y1. And the coordinate of this point is x2, y2. So I want to find out the slope. So that means, you see, I want to find out rise over run. Okay? So because slope is rise over run, and the rise is change in, you see, this is the change in vertical distance, and yes, and this is change in horizontal distance. Look here. So you draw the perpendicular here, you draw the perpendicular here, and you draw the perpendicular here, okay? We did that. This is geometric, okay? I'm going to, derive the formula to find the slope of a line. So, hey, look here, guys. So this point is x1, y1, okay? This point is x1, y1. What is this distance? Can you tell me what is this? What is this? Let's say this is O, P, Q, R, S, T. So what is OP? What is the coordinate of this point S? X1, y1. Is that right? So what is OP? You go how many units from here to P? X1, is that right? So this is x1, and what is SP? Y1. Good. And what is OQ?
X1 to X2.
Yes, this is x2. And so what is PQ?
No, it's X1 to X2.
This is x2 minus.
Oh, X2 minus.
Yeah, this is x2 minus x1. Are you guys with me? Huh? So now look here. Hey, this is my T, okay? This is T, okay? T. What is TQ? What is TQ?
Y2.
Yes, this TQ is Y2. Right? And what is RQ? Look at this is a rectangle, right? This is 90 degree, this is 90 degree, this is 90 degree. Are you guys with me? So what is this? This is y1, right? What is this? y1. See that? Right? So now, if that is the case, hey, can you let me know what is this? Can you let me know what is this TR, this? So what is this? This TR, this?
y2 minus y1.
Exactly. So this is, you see, this is y2 minus y1. y2 minus y1. See that? So now, hey, this is called this SR, this SR. So this is called RON, change in the horizontal distance. You see that? So the RON is this. You see like this SR, which is equal to PQ. So this is also x2 minus x1, okay, x2 minus x1. So the RON is change in horizontal distance, okay, change in the horizontal distance, change in the horizontal distance. So this is RON, and this TR is called rise. You know what I mean? So rise is y2 minus y1. So this one is rise, okay? So let me show that. This one. This is rise. This is rise. TR. And so this is y2 minus y1. So this is the change in the vertical distance. Change in the vertical distance. So now slope is always equal to what? Rise over RON. So in this case, you have y2 minus y1 over x2 minus x1. So this is the formula to find the slope. That makes sense? Now you see, if you know the slope and the point, if you know the slope, if you know the point here, right, and if you know the slope, then you can find the what? You can draw the what? Graph of the straight line. You know what I mean? So yeah, and then if you know 2 points, you can find the slope. And then this x2 minus x1 cannot be 0, okay? Because this is in the denominator, right? Right? Denominator cannot be 0. If denominator is 0, then slope will be undefined. That makes sense? The denominator 0 means your change in horizontal distance, which is RON. RON is 0. Right? So the slope of the vertical line is, you see, when you have a vertical line, look here. When you have a vertical line, what will happen? You have this. This is your x-axis. This is your y-axis. Now, let's say you have a vertical line here. This is your vertical line. Vertical line does not have RON. You know what I mean? RON is the what? Change in the what? Distance, right? Horizontal distance, right? So now here, so this vertical line has RON 0. So that's why the slope of the vertical line is undefined. That makes sense? So let's say this is the vertical line, let's say x equal to 3. Right? Let's say, for example, x equal to 3. So now, if you pick any 2 points, so x equal to 3, so that means you can pick here, let's say this is the point 3, 1, and you want to pick the point here, let's say x equal to 3, y equal to 4, let's say 3, 4. So you see what I'm talking? There is no change in x, no change in x values. It is always 3, right? So now if you want to find the slope, look here. So you have a 3, 1, 3, 4, right? So 3, 1, 3, 4. We have 2 points. So let's say your x on y1 is 3, 1, and your x2, y2 is 3, 4. I consider this point ij x on y1, 3, 1. Are you with me? And then this point ij x2, y2. Okay? And then we have the formula. What is our formula? Our formula is m equals to y2 minus y1 over x2 minus x1. Right? So what is my y2? What is the value of y2? 4. The value of y2 is 4 minus, what is the value of y1? 1. 4 minus 1 over, what is the value of x2? 3 minus, what is the value of x1? 3. You see, m equal to, slope equal to 4 minus 1, 3. What is 3 minus 3? 0. And I told you, if you have something over 0, it will be undefined. So you see, this is undefined. So that's why the slope of the vertical line is undefined. Makes sense? There is no change in the what? Horizontal distance. There is only change in the vertical distance. Did you get it? Yeah. Okay, now you're going to find the slope of the line. It's pretty simple, right? You have a negative 4, 8 and 2, negative 3. You want to find out the slope. So let me erase this. So you have a point x on y1. X on y1, you see you want to find the slope of the line joining the point negative 4, 8 and 2, negative 3. Okay, so your point x on y1 is negative 4, 8, and you can consider your x to y2 as 2, negative 3. Hey, you can consider this side x on y1 or this. Okay, it doesn't matter. Okay, if you may consider this x on y1, this x to y2, or this x on y1, this x to y2. It doesn't matter. It makes no difference. Okay? So now you remember the formula. What is the formula? M equal to what? Slope equal to what? What is the formula?
y2 minus y1 over x2 minus x1.
Yes. So this is y2 minus y1 over x2 minus x1. Right? So now, if you do that, then m equal to, what is your y2?
Negative 3.
Yes, sir. Negative 3 minus, what is your y1? 8 over, what is your x2? 2 minus, what is your x1? Negative 4. Make sense? Now, it will be m equal to this negative 3 minus 8. Yes, negative 11 over this 2 plus 4 is 6, right? So this is the slope. Good job, guys. Yeah. Now for this one, what do you think? You have a 2, 7, right?
That would be undefined, wouldn't it?
Yes. Why it is undefined?
Because x2 and x1 are both 2, so 2 minus 2 would be 0, and you'd be dividing by 0.
Exactly. Yep. You are absolutely right. Because you see the x coordinate is fixed too, right? So if you consider this ij x on y1 and this ij x to y2, your slope is y2 minus y1, which is negative 4. y2 is negative 4 minus 7, right? Over, what is your x2? 2 minus 2. So this is negative 11 over 0, which is what? Undefined. This is undefined. Good. So I think we can do that. Like for this one, what do you think? You have a 5, -3 and -2, -3. So you have a part C. You have a 5, -3 and -2, -3. What will be the slope?
It would be 0 because the y2 and y1 would equal up to 0. Then you'd be dividing 0, which would make it 0.
Yes, sir. That's good. Yeah. So you consider this side the x on y1 and this side the x to y2. So by the way, you know, like when you join these 2 points, it will give you a horizontal line. You know what I mean? When you join these 2 points, it will give you vertical line. Slope of the vertical line is undefined. Slope of the horizontal line is 0. Okay? So now you know the slope equal to -3, y2 is -3, you know the formula, right? y2 minus y1 over x2 minus x1. So m equal to your y2 is -3 minus this is your -3 over your x2 is -2 minus your x1 is 5. Right? Right? So now that will be m equal to, this is 0, right? Over -7, which is 0. So we can do this, okay? Yeah, the slope of a horizontal line is 0. Now, how do you find the slope of this line, guys? How do you find the slope of the line for x plus 3y equal to 12? So, find the slope of the line. Find the slope of the line 4x plus 3y equal to 12. So how do you find it?
Well, wouldn't the domain be negative infinity, comma infinity?
Yes, the domain is negative infinity, comma infinity. That's right. Range is negative infinity, comma infinity. That's also right. So how do you find the slope?
Would you graph the equation to get your 2 points?
Mm-hmm. So I wanna. Do you guys know this? I mean, like we didn't talk about this. This is the equation of the line. Do you know y equal to mx plus b? The equation of the line in slope-intercept form. No. So this is the equation of the line in slope-intercept form. Now let's reduce this into this form. This m is the slope here, where m is the slope, and you should be here, right? That is y-intercept. 0, b is the 0, b is the y-intercept. So now I want to find out the slope of this line. Okay? I want to rewrite this line, which is this equation, right, into this form. That makes sense? So I have a y on the left side, so I will keep y on the left side, and I will move 4x to the right side. So I have a 4x plus 3y equal to 12. So 4x plus 3y equal to 12. Hey, I wanna rewrite this into this form, okay? Okay? So I wanna keep 3y on the left side, and I wanna move 4x to the right side. You subtract 4x from both sides. You cross them out. Make sense? And now what do you have here? 3y equals to, you have a negative 4x plus 12. Right? So now, hey, I only have a y here, right? But the coefficient of y is 3. I want to get rid of this 3. How can I get rid of this 3?
Divide by both sides.
Yes, divide both sides by 3. So you divide here by 3, here by 3. Make sense? Yes? So now you cross them out, so that will be y equal to negative 4 over 3x plus, what is 12 over 3? 4. Now you see, now this is in the form of y equal to mx plus b. What is the value of m? You compare this, you compare with what? You compare with y equal to mx plus b. What is the value of m? Yes. So the m, which is the slope, right, is negative 4 over 3. Did you get it? Good. Yep. You got it, right? Simply solve for y. So now the next one is graph the line passing through the point negative 1, 5 and having slope negative 5, 3. You look at the slides, okay? So you graph the line passing through the point negative 1, 5 and having slope negative 5, 3. So you graph the line, okay? You graph the line through negative 1, 5 and having slope negative 5, 3. Okay. Right? Are you with me? So now look here. It's pretty interesting, right? So this is your x-axis. This is your y-axis. Okay? So where is the point negative 1, 5? In which quadrant this point lie? So this point is located, this is your origin, is that right? This is your origin, is that right? So negative 1, 5. So that means you have to go 1 unit to the left or right from the origin? Left and then, second quadrant, right? So you go like 1 unit left, 1, 2, 3, 4, 1, 2, 3, 4, not to scale, okay? This is not for scaling, you know what I mean? I just give you the idea. 1, 2, 3, 4. So this is negative 1, negative 2, negative 3, negative 4. We have a negative 5 also, right? See that? So negative 1, 5. So this is your origin. You go negative 1 unit left and 5 unit up. Guys, 1 unit up, 2 unit up, 3 unit up, somewhere here. Is that right? Did you see that? I'm not good at it. Okay, hold on a second, guys. Yeah. Looks good, right? So this is negative 1, 5, is that right? This is the point negative 1, 5. And then look at the slope. Look at the slope. What is the slope here? Slope negative 5, 3. So now its slope is negative 5, 3. Okay? So rise. The change in the vertical distance is negative 5. You can think in that way, right? and change in the original distance. Or you can think of this, you know the slope is rise over run. You know the slope is rise over run. And this is negative 5 over 3. Is that right? So you can think in this way, like, so this is your run. So run is the what? Horizontal distance. Is that right? You see that? And this is the change in the horizontal distance, and this is the change in the what? Vertical distance. Is that right? So now from this point, how many unit what is the horizontal distance? 3 units, is that right? So you can go 3 units to the right, because 3 is positive here, is that right? Are you with me? Does that make sense? You go 3 units right, so let me look here. I go 1 unit right, so this if you go 2 units right, and then like, you see this is 3 units right. Are you with me? And then this is, you have a negative 5 is the what? Vertical distance, is that right? Negative 5 means you have to go down. That makes sense? So now how many units down? 5 units down. So now this is 1 unit down, 2 units down, 3 units down, 4 units down, and the 5 units down from here. You know what I mean? That makes sense? And now you join them. Then you can draw the what? A straight line like that. Oh, hold on a second. Ooh, it's not easy to join it. I have to be very careful here. I don't know. Did you guys get it? Something like that, right? So this is one way. Are you with me? Now let's say, hey, this is same as what? 5 over negative 3. It's the same thing, right? Negative 5 over 3 is same as what? 5 over negative 3. You can do that, right? So now, what is this? You have this is negative 3 unit. Now from this point, look here. You go like this. From this point, you can go 3 units left because your run is negative 3. Negative run means you go left. That makes sense? So negative 3. So now look here. So this is, so negative 3. So this is negative 1, negative 2, and this is negative 3. You go here, right? And then this is run is positive 5 means you go, so sorry, rise is positive 5, right? That means you go up. So how many unit up? 5 unit up. Now look here, I'll show you the 5 unit up here. I want to move this to up all the way here. Are you guys with me? Right? So 5 unit up, right? So now let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that, right? So this also goes like a pretty. So now 5 unit up. So 1 unit up, 2 unit up, 3 unit up, 4 unit up, 5 unit up. Did you see that? The same straight line. Did you get it? Yeah. Yeah. Good. Okay. So now, hey, if the line has the positive slope, it will rise from left to right. So what does that mean? So if the line has a positive slope, line, right, with a positive slope, with m positive, the m is slope, okay, slope positive, it rises from left to right. You have x, y, this is your origin, it rises from left to right like this. You see the line rises from left to right, or you have something like this. Are you guys with me? Huh? Or you will have something like this. All these lines have positive slope. Make sense? If you have a line with a negative slope, it falls. And then like hey, look here, if the line side the positive slope, right, the line will be increasing on the entire domain. Entire domain, you know, it's like the line is increasing. If you have a line with negative slope, look here. This is the line with negative slope, right? What is the slope here? Negative 5/3, is that right? Negative slope. You see, it falls from left to right. See that? It falls from left to right. And the line will decrease throughout the domain. On the entire domain, line will be decreasing if it has a negative slope. So the it'll be something like this. Look here. This is your x-axis. This is your y-axis. It might be something like this. It might be something like this. That makes sense? It's decreasing. Right? Now the next is a line with a zero slope, which is the horizontal line. A line with a zero slope neither falls nor rise. Right? If you have a slope 0, so and that kind of line is what? Constant, you know. So if you have a line with slope 0, so that means the line is a horizontal line. It's x-axis, y-axis, and you'll have something like this. This is the So this is the line with this is the horizontal line. Are you guys with me? Did you see that? This line has a slope 0. Hey, this line neither rise nor falls. And you see the graph of the linear function is constant, in a straight line, right? Parallel to the x-axis. So this is a constant function. Constant, okay. And if you have a vertical line, this is your x-axis, this is your y-axis, and if you have a vertical line like this, this line has a slope undefined. Slope is undefined. This is a slope of the vertical line. So now, hey, if you want to find the average rate of change, so we use this formula. Okay? FB minus FA over B minus A. If you want to find out the average rate of change in Y per unit of change in X, then we use this. So this is pretty much same as the what? Slope. So only thing we need to know is this, guys. So you have a x-axis here, you have a y-axis here. This is the function y equal to fx. Are you guys with me? Right? So now look here. So this is your A, right? And this is your B, right? And now this is what? This is the point A, comma FA, and this is the point B, comma FB, right? And if you want to find the average rate of change, you see it pretty much slope, like a y2 is. Now you consider this side the x on y1, and this side the x to y2, right? And now you just do y2 minus y1. So y2 is FB minus your y1 is what? FA. And what is your x2 is B minus what is your x1? A. So this is the formula for the average rate of change. You see that? Now you can find out, using that formula, you can solve this problem, Okay? So yeah, I want to stop here. I will see you next week, okay? Bye.